In this lesson, we're discussing exponential and logarithmic equations, all right? So the property of equality for exponential equations states that two powers of the same base are equal if and only if their exponents are equal. So we're going to suppose that b is greater than 0, b is also not 1, then b to the x would equal b to the y if and only if the x and the y are equal. So like if I had b to the second is equal to b to the something, this has to be 2. Otherwise, the two sides are not the same. So we're going to practice some solving. Now, obviously, on number 1, my bases are not the same. So I want to try to make them the same. So I have a 1/2, and I can write 1/2 with a base of 2 if I give it a negative exponent. So if I said that 1/2 is the same thing as 2 to the negative 1, then I can come over to the other side and write 4 as 2 to the second. So now I have a base of 2 and a base of 2. So that's going to be my goal. Now, is that always a goal we can achieve? No. But if we can, that's the way we should go about it. Now I have this power raised to this power. So I'm going to distribute that -1. So -1 times x is -x. And -1 times 7 is -7. Then I have 2 to the 2 times 3x. So that'd be 2 to the 6x. Now that I have the same base, I know that these are equal if my exponents are equal. So I can take the -x minus 7 and set that equal to the 6x to see what I need x to be in order for the two exponents to be the same. So I'm going to go ahead and add this x to the other side. So now I have -7 equals 7x. Divide by 7. So my x is -1. So on number 2, I have a 25 and a 125. Both of those can be written with a base of 5. So I'm going to replace 25 with 5 squared. That's still being raised to the 3x. And 125 is the same thing as 5 to the third power. And I'm raising that to the x plus 2. So now I'll just multiply those exponents together. 2 times 3x is 6x. And I need to distribute this 3, so 3 times x is 3x, and 3 times 2 is 6. Now that I have those bases that are the same, I know that these are equal if the exponents are equal. So I'm going to set the 6x equal to 3x plus 6 and solve. I'm going to get my x's together, so subtract the 3x. That gives me 3x equals 6. Divide by 3, and x is 2. So on number 3, I know that 0.001 is the same thing as 1 over 1,000. So I'm going to write that as a fraction. And if you have a fraction and then like a whole number as your base on the other side, you know that that fraction is going to have a negative exponent. So I'm just going to think to myself, this has a base of 10 already. Can I make this a base of 10? That would be 10 to the negative third power is equal to 10 to the 6x. So now that my bases are the same, I set the exponents equal to each other. So -3 equals 6x. Divide by 6. So x is -1/2. All right, so I have 16 and 256. So I know that I can use a base of 2. So 16 is 2 to the 4th. And that's still being raised to the 3x. 256 is 2 to the 8th, and that's being raised to the x plus 1. So I have 2 to the 12x is equal to 2 to the 8x plus 8. Now I set those exponents equal to each other since my bases are the same, and then I just solve. So I'm going to subtract the 8x. That gives me 4x is equal to 8. Divide by 4. So x is equal to 2. All right. So the property of equality for a logarithmic equation states that two logarithms of the same base are equal if and only if the arguments are equal. So x is going to be greater than 0. So if log base b of x equals log base b of y, if and only if the x equals the y, which makes perfect sense. All right, so if I'm looking at number 5, all right, 17 is a prime number. 4 can only be written with a base of 4 and a base of 2 because 2 squared. I can't write 17 with a base of 2 or a base of 4, which means I'm going to have to use a log to solve. So I know that I could do a log with a base of 4 since this exponent has a base of 4. So if I do that on both sides, that gives me log base 4 of 17 is equal to log base 4 of 4 to the x. This cancels, so I know that x is equal to log base 4 of 17. Now I could plug in log base 4 of 17 and get an answer, but it's going to be a decimal, so I'm just going to leave it like that. Same thing here. I have a 5 and a 12. 5 is a prime number, so I can only write it with a base of 5. 12 only has 2, 3, and 6 that go into it, and 12. So 5 doesn't go into 12 at all. I can't make it with a base of 5. So I'm going to have to do a log, and since this exponent has a base of 5, I will use a base of 5. So we have log base 5 of 5 to the x equals log base 5 of 12. This will cancel. So x is equal to log base 5 of 12. All right, so number 7. There's supposed to be an x right there, so adding it last minute. All right, so this time, this is different from 5 and 6 because on 5 and 6, only one of them had a variable in the exponent. On this one, both of them do. So I can't do a log base 3 on one side and a log base 5 on the other. So instead of doing that, I'm just simply going to log both sides. So we're just going to log with a base of 10. All right, we can choose whatever base we want to. We normally do the base of the exponent, but since we have two different ones, it's kind of impossible to do that. So we have log base 10 of 3 to the x plus 1, log base 10 of 5 to the x. All right, now the point in doing that is because anytime I take the log of something, I can move the exponent to the front. So I can take this x plus 1 and I can move it in front of this log right here. And I can take this x and I can move it in front of this log. So since this is two terms, you're going to need to put it in parentheses. So you have x plus 1 times log 3 and x times log 5. Now, this log 3 is getting multiplied by two terms. So we're going to distribute. So we have x times log 3 plus 1 times log 3, which is just log 3, equals x times log 5. Now, the problem is that we have an x here and we have an x here. When you have an x in two different terms, you need to get those terms on the same side so that you can factor out that variable that you're solving for. So I'm going to subtract the log 3 to move it to this side. And I'm going to subtract x log 5 to move it to this side. So I have x log 3 minus x log 5 is equal to negative log 3. Now I have a common factor between these two terms, so I'm going to factor the x out. So if I divide that out of the first term, I'm left with log 3. And if I divide it out of the second term, I'm left with negative log 5. That's equal to negative log 3. Now, since this is x times all of this, I can divide by log 3 minus log 5. So x is equal to, now if I wanted an exact answer, it would be negative log 3 divided by log 3 minus log 5. We're going to go ahead and plug that in and get a decimal. And we'll round, we're going to round 2 decimal places. All right, so I'm going to get a fraction. In the top, I have a negative log 3. On the bottom, I have log 3. Make sure you close that parenthesis right there. Minus log 5. So I get 2.15. So if you look at number 8, again, you can't make 2 and 7 written with the same base. Also, they're both the base of an exponent, so therefore I can't do a log base 2 on one side and a log base 7 on the other, so I'm just going to do a base 10 log. So we'll log the left side and we'll log the right side. And the point in doing that is so that we can pull these exponents to the front. So I have 3x log 2 is equal to 2 terms here, x plus 1, times log 7. So I'm going to have to distribute this log. So the left side, I just have 3x log 2. This will give me x times log 7 plus 1 times log 7. And this is another situation where I have an x in this log and an x in this log, so I want those on the same side. So I'm just going to subtract this x log 7. So I have 3x log 2 minus x log 7 equals log 7. I'm going to factor out the part that's common, which is just the x. So factor out the x. That means here that would leave me with 3 log 2 minus log 7. And I don't know why I put that little parenthesis right there. So we'll take it out. Equals log 7. Now I can divide by the 3 log 2 minus log 7. We'll plug that in. When you plug that in, you're going to get 14.57. All right, so number 9. On this one, I see that I have a log base 5 is equal to, a log base 5 of x squared minus 44 is equal to a log base 5 of 7x. If you have a log base 5 equal to a log base 5, that means these parts have to be equal. So I'm just going to set them equal to each other. So x squared minus 44 equals 7x. I see I have an x squared and an x and a number without an x, so a constant. So I'm going to move the 7x over because that tells me I'm going to have to probably factor. So x squared minus 7x minus 44 equals 0. And then we're going to factor this. So since we have a minus in back, we have one positive and one negative. We have our x and x. And what multiplies to make 44 that subtracts to make 7 is 11 and 4. And 7 is negative, so 11 has to be negative. And 4 has to be positive. And then I set those equal to 0. And I solve. That gives me negative 4 and positive 11. Now, when you have a log in your original equation, you have to make sure that your answers will work with that log. Remember, you can't log 0 and you can't log a negative number. So I have to think to myself, if I plugged in negative 4 here, that would give me negative 4 squared minus 44, so 16 minus 44. Is that a problem? Yes, it is. That gives me a negative number. Also, if I plug in negative 4 here, I have 7 times negative 4. Well, that's negative 28. I can't use negative 4. That's considered extraneous. So try 11. 11 squared minus 44, that's positive. 7 times 11, that's positive. So 11 is an answer that works. So negative 4 is extraneous and 11 is your actual answer. All right, we only have to worry about that if there's a log in our original equation that we are given. All right, so number 10. I can see that the x I'm trying to get to is in this exponent, but we have this 4 being added, so I'm going to subtract 4 first because I need to isolate that base with its exponent. So that gives us 5 to the 6 minus x equals 11. All right, now notice this 11 over here does not have an exponent. So to get rid of this base of 5, I can do a log with a base of 5. If both sides have an exponent with a variable, then you're probably not going to be able to do that unless you can make your bases the same. So this is going to cancel. I have 6 minus x equals log base 5 of 11. All I have to do is subtract 6. And remember that 6 does not go with that 11. So that gives me negative x equals log base 5, 11 minus 6. And then I just divide by negative 1. And you will just plug that in your calculator as is. That gives me 4.51. Now, you could have just logged both sides like we had done on 7 and 8. And you're going to get the same exact answer. It really doesn't matter. You can do it both ways. All right, number 11. So I have a 2 to the 3x minus 2 and a 5 to the x. So that tells me that I have a problem here. I can't make the 2 with a base of 5. I can't make the 5 with a base of 2. So we're going to have to log both sides. So I have log 2 to the 3x minus 2. And I have log of 5 to the x. I'm going to pull those exponents to the front. So 3x minus 2 times log 2. Pull the x. So we have log 5. Distribute this log. So we have 3x log 2 minus 2 log 2 equals x log 5. So since I have x in two different locations, I want those on the same side. So I'm going to subtract this x log 5 on both sides, and I'm going to add this 2 log 2 on both sides. So that gives me 3x log 2 minus x log 5 equals 2 log 2. And then I'm going to factor out that x. That leaves me with 3 log 2 minus log 5 equals 2 log 2. Now I'm going to divide by the 3 log 2 minus log 5. And then we're going to plug in the 2 log 2 divided by 3 log 2 minus 5. So 2 log 2 divided by 3 log 2 minus log 5. So we get 2.95. All right, so number 12. I see that I have this 2 in front of my natural log, and I have it equal to another natural log, but I can't do anything with this 2 in the front. So I'm going to move it up into the exponent. So now I have natural log of 3x minus 2 squared equals natural log of 5x plus 6. Now that I just have a natural log equal to a natural log, I can go ahead and set the parts equal to each other. So I have 3x minus 2 squared. Remember, that's 3x minus 2 times 3x minus 2. So you have 3x times 3x, that's 9x squared. Then you have negative 6x and negative 6x. That's going to give you negative 12x. And negative 2 times negative 2 is positive 4 equals 5x plus 6. So this tells me that I'm going to end up having to factor on this one as well. So I'm going to go ahead and subtract the 5x and the 6 to move them to the left side. So I have negative 12x minus 5x, which would be negative 17x, and 4 minus 6, which is negative 2. And since I have a number in front, I'm going to have to do the illegal move. So this will make x squared minus 17x minus 18 equals 0. Then I can factor. So I have a positive and a negative, x and x. And what multiplies to make 18 that subtracts to make 17 is 18 and 1. 17 needs to be negative, so 18 will be negative, 1 will be positive. And then I need to undo what I just did by dividing by 9. Now, if I was just factoring, I would pull that 9 to the front. But since I'm solving, I will leave it back there. Now I'm just going to set these equal to 0. That gives me negative 1/9 and positive 2. And if I check those, since I had a log in my original equation, if I check those, the negative 1/9 is going to be extraneous. So 2 is our only answer that is correct. All right, number 13. So I need to isolate where my x is. So I'm going to go ahead and add 12. That gives me 9 is equal to 1/2 to the x. Now notice 9 does not have an exponent. It doesn't have a variable in its exponent. So I can get rid of the 1/2 base by doing a log with a base of 1/2. So x is going to be equal to whatever log base 1/2 of 9 is. And that's about negative 3.17. All right, so if you look at number 14, you have a log on the left, a log on the right, but then also this like plus 4 at the back here. I want to put my logs on the same side so that I can put them together. So I'm going to subtract this log base 2 of x minus 1 to the other side. So that gives me log base 2 of 3x minus 2 minus log base 2 of x minus 1 equals 4. Now I need to put these logs together, and I know that if I'm subtracting two logs, I can divide their parts. So I have log base 2 of 3x minus 2 divided by x minus 1 equals 4. Now that my log is together and alone on that left-hand side, I can use a exponential base of 2. So I'm going to take 2 and raise it to the log base 2 of 3x minus 2 over x minus 1. And again, 2 and raise it to the 4th power. So now I have 3x minus 2 divided by x minus 1 equals 2 to the 4th, which is 16. Now I need to get this x off the bottom, so I'm going to multiply by x minus 1. And since it's two terms, you need parentheses around it. So those will cancel. I have 3x minus 2 equals, distribute that 16, 16x minus 16. Now I'm just solving, so I'm going to subtract 3x to get that with my 16x and add this 16 to get that with that negative 2. So that gives me 13x is equal to 16 and negative 2, which gives me 14. Divide by 13. So x is 14 over 13, so a little over 1. So just make sure that if you were to plug into this log and this log, that would not give you a negative number. It doesn't, so that is your answer. All right, now we're going to solve by graphing, okay? So you're going to take one side and make that your y1, and the other side and make that your y2. So for my y1, I have log of 2x plus 1 squared, not squared, to the 5th. And then the other side is x minus 2. So if you go to your graph here, the answer is where they intersect. So it's right here. It's not a pretty point, okay? So we're going to use the intersect feature. So if you go second and trace, that's the calculate menu, and we're going to calculate the intersect. So you're going to choose 5. So it's going to ask you first, like, which one is your first curve? Well, that's the blue one. So if you look up here, it's in blue. It's showing you that this is the first one. Press enter. Then it's asking, is this the second one? And notice it's showing you the second equation in red. Press enter. And then it says, do you want me to guess where they intersect? Press enter. And it should hop right there to where they intersect. You need the x value because you're solving for x. So that would be 2.21. All right. So on number 16, this left side will be the y1. This will be the y2. It really doesn't matter which one is which, as long as you have one side in one of them and one side in the other. All right, so we're going to clear both of those other ones out. So we have 3 times x to the x plus 2 minus 1. Make sure you hop down out of that exponent. The other one is 3 minus x. We're going to go to our graph. Obviously, they are crossing right here. I mean, it looks like it's at 1 to me, but we're going to use the intersect feature. So second trace, which gets us that calculate menu, we're going to choose 5. So blue is first, enter. Red is second, enter. Guess, yes. All right, and in fact, it is an x value of 1. All right. The diagram shows how a forest fire grows over time. The fire department can contain a 160-acre fire without needing additional resources. About how many minutes, so we're looking for a time, does it take for a fire to become too big for the fire department to contain without additional resources? Round to the nearest minute. So obviously this has a growth rate because we go from 4 to 7.2, 12.96, 23.3. So to find that growth rate, we are just going to take 7.2 and divide it by 4, or you could do 12.96 divided by 7.2, or 23.3 divided by 12.96. It doesn't matter. The growth rate is going to be the same on all of them. So for our growth rate, I'm just going to take the 7.2 and divide that by 4. That gets me 1.8. So I know that they can do 160 without needing additional resources. My original acreage was 4. My growth rate is 1.8. And that's raised to the time, which is in minutes. So we have a growth rate exponential function here. All right. Now I'm just going to solve for the m. So I need to get rid of this 4 first. So I'm going to divide by 4. So I have 1.8 to the m is equal to 160 divided by 4, which is 40. Now to get rid of that exponential base of 1.8, I need to do a log with a base of 1.8. So log base 1.8 of 1.8 to the m is equal to log base 1.8 of 40. So I'm going to plug in that log with a base of 1.8 to the 1.8 of 40. And you're going to get a little bit over 6, but it says to the nearest minute. So this would be 6 minutes.